In this video, we're going to talk about the probability distribution for a discrete variable. So a reminder that a discrete variable is a numerical variable that represents a count. So usually that means our variables can take instances of integers here. And we'll see an example of that here in a few minutes. But more formally, for the definition here, a probability distribution for a discrete variable is a mutually exclusive list of all possible outcomes along with the probability of occurrence of each outcome. Now let's go ahead and take a look at an example to see what this might imply. So let's look at an example where we see the probability a student eats off of campus a certain number of times per month. Okay, so the number of times that they are eaten off the number of times they eat off campus each month will be a list of integers, right? And they might eat 0 times, somebody might eat 1 time, 2, 3, and let's just assume that nobody that was surveyed ate more than 7 times off campus each month. Well, along with each of these is a probability. So we survey a lot of students and we see a probability associated with each of these values. And suppose 5% of the students that we surveyed eat 0 times off of campus each month. And then so on down this list, 0.1, 0.15, 0.15, 0.25, 0.1, 0.1, 0.1. Okay, so again, we're just supposing we have this data, this information, and this is a probability distribution for a discrete variable. Again, the discrete variable, because this represents a count. In this case, the number of times that students eat off of campus each month. And then we survey a lot of students, and we say 5% of them fell into this category, 10% fell into the category of eating off campus 1 time a month, and so on. Now, one thing we can do with this kind of information is we can certainly graph it. So how do we graph a probability distribution of a discrete variable? Well, we do so using essentially a vertical bar chart, although it's usually with lines. So 0.05, 0.1, the highest we ever went here was 0.25. And along the x-axis, so our y-axis is our probability. Along the x-axis is the count. So the number of times eating off campus. But in general, what would that be? Again, that would be our count or our integers along the bottom here. So 0, 1, 2, 3, 4, 5, 6, 7. And we just have a vertical line to represent the probability. So 0, it was 5%. 1 time off campus was 10%. 2 times off campus was 15%. 3 times was also 15%. 4 times was 25. And then 5, 6, and 7 were all at 10% each. And so this is an example of a graph of a probability function for a discrete variable. Okay, now let's take a look at calculating some things related to that. And the first thing that we're going to calculate is the expected value. Now, the expected value you can think of as the mean. So think of this as the mean. It's not technically the mean. This is something different because we have to calculate it in a different way. But in this scenario, you can kind of think of it as the mean of this situation. All right, so what is the expected value? The expected value of a discrete variable is the population mean of its probability distribution. Okay. And what is that? Well, what's our actual formula for that? This is mu, the expected value mu. So mu is equal to also e of x. We might use that notation for this as well, for the expected value of the discrete random variable x. And this is the sum from I equals 1 to capital N of x sub I times, and then we have this notation, p of x equal to x sub I. And let's write down what all of those mean, where x sub I is the ith value of the discrete variable. P of x equal to x sub I is the probability of occurrence of the ith value of x. And finally, capital N is just the number of values of the discrete variable x. Okay. Now I'm going to go ahead and do a quick example of calculating this using the information we were given in this particular example. So how do we calculate this? Well, mu is equal to the first value is 0, right? The x sub I is 0. Our first count or variable there is 0, times the probability of occurrence. Well, the probability of occurrence of 0, eating off campus 0 times a week, was 0.05 or 5%. And then this says we're taking the sum of this product as we move along from I equals 1 to n. So our first variable was 0, and the probability of that was 5%. Now we add up the second variable. The second variable was 1, and the probability of that is 0.1 plus, and so on. So the second variable was 2 times its probability plus 3 times its probability plus 4 times its probability plus 5 times its probability plus 6 times its probability plus 7 times its probability. And all of that is 3.65. So our expected value is 3.65. In other words, if we surveyed something like 50 students and they all fit within this set of data, then we'd expect the total number of times eaten off of campus by those 50 students to be 3.65 times 50. And by expected value, we just mean that the number of times should be close to that. That's what we expect to happen. Clearly, it doesn't have to happen that way. If you'd surveyed 1 million people in the first place, there are more than 50 that would have eaten 0 times off of campus each month, if 5% of them did. So it's possible that we could have selected those 50 people, so maybe we would have had the students eating off the campus 0 times per month. But this expected value says that if we chose randomly, this is what probably should happen on average per student. And that's what that means. We have 2 more things we're going to calculate real quick and talk about in this section. So we'll finish that up real quick. If we've talked about a mean, then of course we need to discuss the variance and the standard deviation. So the variance of a discrete variable is sigma squared equal to the summation from I equals 1 to capital N of x sub I minus e of x squared, times the probability of x equal to x sub I. And this is our variance. Now, how do we calculate that? Let's go ahead and start this calculation. Maybe we'll go ahead and write it all out as well. So this first part is x sub I minus e of x. So x sub I for I equals 1 was 0 minus our expected value, which was 3.65, so we just calculated. We square that, and we need to multiply this by the probability of x sub I occurring. And recall that that was 0.05 or 5%. Plus, our second value was 1 minus the mean, all of that squared, times the probability that 1 occurred, and that probability was 0.1 or 10%. Plus, and we go to the next one, which is 2 minus the expected value, quantity squared, times the probability of 2, and that was 0.15, plus, and we keep doing this until we get to the very end, where we had 7 minus 3.65, quantity squared, times the probability of 7, which was 0.1. And again, I skipped over writing out all of the stuff because they were taking a little bit longer, but we also had 3, 4, 5, and 6 in here. And furthermore, this is our variance. And finally, our standard deviation is, and standard deviation is just sigma equal to the square root of sigma squared. So after we calculate this up here, take the square root to find your standard deviation. All right, and that will end this video.